Here we have a 10 centimeter by 10 centimeter by 10 centimeter cube, and it's full of little orange cubes like this one. These little orange cubes are 1 centimeter on a side. Take a good look at that. Okay, I'm going to put that in here, and also then we have rows of 10, because of course each of these is a 1 centimeter cube. We're going to need 10 of them to make a row. Here's another row. Let's put that row in there carefully so it doesn't break apart. Of course it's attached, so it's not going to break apart. So there's another row. Now if you look at the top of this thing, you might not be able to see the lines of demarcation between one cube and the next, but you can understand that we are going to need 10 such rows to just cover the top. Oh, okay, I'm down below the camera. We're going to need 10 rows of the same type to go from here to here. So now we have 10 rows on the top layer, each row consisting of 10 little cubes. Then of course we have 10 layers, because each layer is 1 centimeter thick, and this is a 10 by 10 by 10 centimeter cube. And now we have 10 layers, each with 10 rows, each with 10 cubes. And as I said in class, we then conclude, and of course this isn't true, but I said, okay, so we conclude that there are 10 plus 10 plus 10, which is 30 little cubes in the whole container. And people looked at me like I was crazy, because they know there are more than 30. They can see that there are more than 30. But I asked them, well, what's wrong with that? What's wrong with that calculation? Well, you know, what's wrong with that calculation is that I've got the wrong operation. Okay, it's not 10 plus 10 plus 10. Each row is 10, and there are 10 rows. So there are 10 and 10 and 10 and 10 and 10, 10 times here. So 10 plus 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 10 is 10 times 10, which is what we have on this first layer. So it's 10 times 10, not 10 plus 10. Okay, 10 plus 10 would be only 2 rows, right? And then we have to multiply that by 10, because we have 10 layers. So there's a reason we multiply. We want to be sure we do that. We want to be sure we don't grab the wrong calculation, which is very easy to do if you just put numbers together in some random fashion. You have to be very meticulous, very careful that you understand what you're doing at every stage of your reasoning. Okay, well, the first, and we assume that everybody's seen this because we've done this in class before, but the first question that arises is, or the first question that's posed on the document is, okay, if we have a 40 centimeter by 40 centimeter by 40 centimeter cube, how many of these cubes would it take to fill it? And I don't mean the little tiny cubes, I mean how many of the 10 centimeter cubes. Now what people did was they started putting numbers together, sometimes in a reasonable way, sometimes in a not so reasonable way. Some people said, okay, well, we got 40 layers, 40 rows, and 40 cubes. Complete my sentence, as I kind of tell people to do, kind of emphasize telling people to do that. So that would be 40 times 40 times 40, or 64,000 1 centimeter cubes. Now that's not the answer to the question, but that's a good set of reasoning if you specify 64,000 1 centimeter cubes and realize you're not saying we have 64,000 10 centimeter cubes. Of course, what I would see most commonly is just 64,000 without saying what that is, and that's a completely wrong answer to the question. Okay, not completely wrong, because I know what you did, and I know you did something that was reasonable and something that was right. You left out something, you failed to think about something. But if I was grading the test, I would give you significantly more partial credit for saying 64,000 1 centimeter cubes than for saying just 64,000 and not identifying what it is you're talking about. Okay? if you say 64,001 centimeter cubes, just from the perspective of getting graded correctly, or graded most favorably, you're going to be graded more favorably there because this does describe something that's directly relevant to 40 centimeters on a side. Okay? Whereas again, 64,000 doesn't say 64,000 what. From a perspective of getting in good thinking habits, getting in the habit of good documentation, getting into good communication habits, you want to write that down. You want to write down what it is. Don't just write down a number. And when you solve a problem, don't just have a bunch of numbers in your paper that are unconnected with no documentation, no indication of why this number is used or this number is related to that number. And of course, I also saw a question or answers like 4,000. Okay, now I know what you would do to get 4,000. You'd say, well, 40 centimeters, and I've got this thing that's 10 centimeters, so I'm going to do 4 of them. And that's going to give me 4,000 little cubes. Well, that's insightful, but it's not quite correct because you haven't built a 40 by 40 by 40 cube, have you? Okay, so real important to write down meanings and to think about what it means to think and communicate clearly. Okay? I went into digression in class about something. I looked up something about, there was a lyric in the song King of the Road. Very famous crossover country song. I would assume everybody with reasonable cultural experience would know, but nobody seemed to. But of course that song's, nearly as old as I am, so I can understand that. Okay. And I just saw some comments, about the meaning of the song and saw where people had just totally missed certain meanings. I'm not going to go into the detail of that. Now, whether you get the meaning of that song or not, I think about the public discourse that goes on in the internet, and people do equally silly, ignorant things when they're trying to communicate. They misinterpret, they see what they think they're seeing, and they don't see what's there. So if you think there's 64,000, if you think 64,000 is an answer to this question, you're missing something important. And if you can see things clearly in a mathematical problem, you're more likely to see them clearly in everyday questions, in everyday conversation, in everyday debate. And I think it's really important to have that. And of course I went on to some hyperbole about how just by doing this and writing things down clearly and thinking clearly in this class, you start a movement that permeates throughout society and delays the collapse of Western civilization or decreases the probability of the collapse of Western civilization over the next 100 years. And of course I'm just being facetious about that, but you want to think there are serious questions that are involved with seeing things and thinking clearly. Okay, well, I don't want to digress any more than that. So what is the question? The question is, how many 10 centimeter cubes does it take to make a 40 centimeter cube? Most people went off and found out how many little cubes it takes to make the 40 centimeter cube, which is a good result, and I respect that and would give serious partial credit to that, especially if it was clearly identified 64,000 what. But that's not the answer to the question. The question is 64. Okay, well, having calculated the 64,000, you can get the 64 because you know there are 1,000 little cubes in the 10 centimeter cube. Okay, so you can take the 64,000, divide it by 1,000, and find that there's 64 times as many, and then look at the document and look at the question that was actually asked, and you see that this is the completely correct answer to the question. This would be respectable. Just plain old 64,000 would be semi-respectable. 4,000 less so. But if you had a 4,000 and showed you reasoning, it would be more so. Okay, well, there are lessons, number of lessons to be learned in answering this first question, the first sub-question on the first question. We'll go on in the next video and look at other ways we could have obtained this, because this really leads to the whole idea of proportionality and variation, something people don't understand very well because it's not taught very well. And hopefully we'll be able to make some progress with the whole idea in this course.